Hello and welcome to the session. In this session, let's learn about representation of hypothesis, hypothesis space, and attribute value pairs. Let's first revisit what is hypothesis in machine learning. See, hypothesis is a fundamental concept in machine learning and data science. Hypothesis serves as an initial assumption which is made by a data scientist or any machine learning professional when he is trying to address a problem. So the term hypothesis and models, or when I say machine learning model, sometimes it can be used interchangeably. However, there is some subtle difference between hypothesis and model. Hypothesis represents an assumption, while model is a mathematical representation which is employed to test the hypothesis. So, in formal definition, hypothesis in machine learning is the model's presumption, or let's say assumption, regarding the connection between the input features and the result. Let's now try to represent hypothesis. See, hypothesis, which is represented by small h, it approximates a target function. So as I said, hypothesis represents an assumption, right? It represents a connection between the input features and the output result. So hypothesis, let's represent it with small letter h. It approximates the target function. Basically, it represents the relationship between the inputs. In the inputs, I can have independent attributes. I can also have dependent attributes. What are the inputs? They are the training instances which we are giving for our model to learn. So our training instance will have independent attributes, it will have dependent attributes. Now, and there is a target function. So a hypothesis is approximating the relationship between the target function f to the training instance. So basically, hypothesis is a predicted approximated model that best maps the inputs to the outputs. Each hypothesis is represented as a conjunction of attribute conditions in the antecedent part. So basically, conjunction means what? I have a set of attributes in my training instance. So I am going to find a relationship between these attributes. For example, here in the last session we took an example of elephant, right? Some features, what are the features which are required for an elephant? Let's say the tail has to be short and the color is black. So, and you're basically representing the relationship between these two attributes. Now, I need both these attributes, right, to represent or to say that this is an elephant. So, this is the conjunction or relationship which is established between the two attributes. So, hypothesis also represents the conjunction between the two attributes here. So set of hypotheses, I will not have just one hypothesis in my hypothesis space. I will have a group of hypotheses. So that group of hypotheses is called hypothesis. You can see the difference between this term and this term. So basically, when I say hypothesis, THESES, it is a plural form of hypothesis, THESIS. So hypothesis is one and the plural form is hypothesis. THESES is the plural form of this. So note the spellings. So generally we'll be using capital H, right? Capital H is used to represent the hypothesis. Capital H is used to represent the plural form, and small h is used to represent the singular form of the candidate hypothesis. Now, the last session we saw about, just to revise, in the last session we saw, right, this is suppose our training instance, right? This table represents the training instance to identify whether it is an elephant or not. So what do we see here? We have some 8 features here: horns, tails, tusk, paws, fur, color, hoof size. So we are giving 8 attributes and there are 5 training instances, right? So let's say this is what we are having in our training data set. Right now, the hypothesis will basically try to represent the conjunction between these attributes. Each one is one attribute. And what is a conjunction? That conjunction or a relationship, the conjunction is horns, no, and, tail short and, tusk yes and. So basically I'm going to conjunct each attribute. So that would be done in the hypothesis, right? So if you come back to this slide here, write each attribute here as an attribute and a value. So the attribute is horn, the value is yes. If the attribute is color, the value is black, brown. So each attribute will have an attribute and a value pair. Now what are the values that it can take, right? See, either it can hold a single value. You can say single value in the sense I will say the color, right, where I will say black, brown, orange. That would be the single value. Or the attribute can have a question mark, or it can have a null value. If the attribute has a question mark, that means it can take any value. So if I write question mark in the attribute, it means it can take any value. If I say color is equal to question mark, it can take any value. If I say attribute is equal to null value, that means it cannot take any value, no values. It's a null value, not even 0. So this is a null, right? So that means it cannot take any value, not even 0, right? It's a null value. And it can also take a single value. So we can say tail as short. I can say color as black. So that would be a single value. So every attribute can either take question mark, or it can take a null value, or it can hold a single value. Now let's take an example. So we saw now just the previous is, right, I had some 8 attributes and I had 5 training instances. So if I want to write a hypothesis, suppose I have written the hypothesis small h, that is a singular form of hypothesis, like this. So what have I written here is horns no, tail question mark. So that means it can take any value, right? Paws also it can take any value, fur also it can take any value. But black, no, s and no, these are the singular values. In this example there is no null value. So given a test instance x, we say h of x is equal to 1 if the test instance x satisfies this hypothesis, right? So if I have a test instance x, and I can say that the h of x is 1 if this condition is satisfied. The hypothesis is 1 if this condition is satisfied. Okay, so I just showed you the table where I had a training data set where I had some 5 training instances and 8 independent attributes. Here different hypotheses can be used to predict the target concept. So this is another hypothesis. See, this is one hypothesis, this is another one, or I can also have a hypothesis like this. So here I am saying the hypothesis is 1. That means let's say the hypothesis is 1 means let's say it's an elephant, right? If the elephant is 1, that means hypothesis is 1. If no horns, like tail can take any value, tusk is s, paws and fur can take any value, color black, no hooves, size medium. Just a case study, right? Just an example. So here I can write my hypothesis in different ways, right? So basically the task is to predict which is the best hypothesis to say that it is an elephant or not. To say that it's an elephant or not, that is what is called as target concept. We discussed concept learning in the last session. Concept learning is all about decision making, right? Where we categorize make decisions. Here in this case we categorize based upon the features, these 8 features. So the most general hypothesis can allow any value for each of the attributes. So you should write the best hypothesis. The best hypothesis is one which is the most general one. Okay, so the most general hypothesis means all the values will be question mark. That means it can take any value. So if I say all the attributes as question mark, that means this hypothesis indicates that any animal can be an elephant. If I write a hypothesis like this, where I am saying all the 8 attributes as question mark, it means that any animal can be an elephant. Or if I want to write the most specific hypothesis, then it will not allow any value. That means all the values are null values, right? So if I write all the values as null values, it means this hypothesis indicates that no animal can be an elephant. So this is just an example, okay, to show you the difference between general hypothesis and specific hypothesis. This is an example of general hypothesis. If I write general hypothesis, all the values will be question mark. If I write all the values as question mark, in this case it means that any animal can be elephant. If I write the most specific hypothesis, all the attributes will be null value. It means that any value, it cannot take any value, no values. So that means no animal can be an elephant. This is just an example to illustrate what's the difference between general hypothesis and more specific hypothesis. So the target concept mentioned in this example, which is the target concept here, to identify whether it's an elephant or not. So basically we have to identify the conjunction of the different attributes. So that is our goal. So what is our target concept? I have to identify the conjunction between these different attributes to correctly identify whether it's an elephant or not. So let's see that in the next slide. So this is the question. Explain concept learning task of an elephant from the data set is given. So this data set is given. So how do you do concept learning task for this? So what do we see in this figure is there are 5 training instances and 8 different attributes. What is the target concept function? The target concept function, let's say I denote it by small c colon elephant, yes or no. So my target concept or target function is I have to identify whether it is elephant or not. Next, define your hypothesis H, capital H. Okay, capital H means plural form. THESES. That means what is my set of hypothesis? My set of hypothesis will be conjunction of the attributes, right? So what is the solution here? Let me write the hypothesis small h for the concept learning of elephant task like this. Okay, so let's say horn is no. This is one hypothesis that I am writing. Let's say horn is no, tail is short, tusk is yes, paws and fur, let it take any value, color is black, hooves is no, size is any value. So I have to now express the relationship between these attributes, which we call it as propositional logic form, right? This small h I will represent in the propositional logic form like this. I will just write horns is equal to no, conjunction, tail is equal to short, conjunction between this. So just write the relationship between this, find the relationship between the different attributes with this conjunction value. So what is a output of this hypothesis? This is my hypothesis, one of the hypothesis, not the best. I am not saying this is the best, one of the hypothesis. So what is the output? We learn from the hypothesis small h to predict an output as elephant such that given a test instant x, small h of x is equal to c of x. So what is my goal? I have discussed in the previous sessions. The goal is what? Our predicted hypothesis and our target hypothesis should be same, or at least approximately same, right? We have an ideal hypothesis and predicted hypothesis should be approximately same. So this is our predicted hypothesis. Small h x is the predicted hypothesis. C of x is the ideal hypothesis. Our goal is both h of x and c of x should be same. So this hypothesis produced is called as concept description, which is a model that can be used to classify the subsequent instances. So basically the goal or the output of our concept learning task is ideal hypothesis C of x should be same as the predicted hypothesis h of x. Okay, so that is C. So this is what is all about concept learning task of an elephant. So let's now just learn about a different concept. What is hypothesis space? As the word itself says, it's a space. It is a set of all the possible hypotheses, small h, that approximates the target function f. So that's what I'm saying. The hypothesis should always approximate the target function. Target function is nothing but your ideal function, right? So it is a set of all possible approximations of your target function, and all that is grouped together as hypothesis space. So basically our goal is describe the target function that best fits the outputs. That is our goal. The goal of hypothesis space is to describe the best target function that best fits the output. We are learning in the next few sessions lot of machine learning algorithms, and all the machine learning algorithms we'll be learning about decision tree, we'll be learning about SVM, regression algorithms, whatever algorithm of machine learning it is, all of them represent the hypothesis space. All the machine learning algorithm represent the hypothesis space, and the goal of that will be a function, a target function that maps the input variables to the output variables. Let's say I have a machine learning algorithm for regression algorithm. So it represents a hypothesis space as a linear function here. Or let's say we are discussing about decision tree algorithm. Here again we represent the hypothesis space as a tree. So it's just a different way of how I'm representing my hypothesis space. My hypothesis is a set of hypotheses. I can represent it in different ways. For linear regression algorithm, I represent it as a linear function. For a decision tree algorithm, I represent the hypothesis space as a tree. Just a different way. But remember this, every ML algorithm represents the hypothesis space. So that was about hypothesis in today's session. In the next session, we'll discuss about version space learning in machine learning. Thank you so much, and please subscribe to the channel. Thank you.